Hello everyone, this is Ivan and I am glad to see you again. And today I would like to introduce to you a little bit of networks and network theories. First of all, let's talk a little bit about graph theory and network nature. Today we will try to analyze some air navigation networks and try to estimate basic performance of graphs. In this case, we will represent air navigation networks as simple undirected graphs and try to perform some assessment. First of all, let me show you two typical examples of networks. First of all, it is a flight routes network of Ukrainian airspace. In this case, each waypoint is represented as a node of graph, which is connected by multiple edges, which represents some airways. And applying network theory, we can estimate the most overloaded waypoints and try to find solution how to reduce workload of particular waypoint. In other examples, it is usage of network theory to navigational aids configuration estimation. And in this case, you also can see network of ground-based navigational aids in Ukraine. Each of navigational aids has specific identification code. And here you can see result of estimation knots degree by color in Ukrainian distance measuring equipment ground network. First of all, let's talk how we can set up a graph and what is a graph. In this case, graph can be setting up with the adjacency matrix. Adjacency matrix, this is diagonal matrix, which is symmetrically based on the main diagonal of this matrix, which is equal to 0. And adjacency matrix, usually it is a binary matrix. Elements of each can have value 1 true or 0 false. However, in graph analysis, maybe we can add some weight for each edge, because usually network has a particular configuration and edges has different distances. Thus, one edge may be short, another one can be quite long. And in order to estimate configuration, we need to introduce weight of each edge in our adjacency matrix. To do that, usually used weighted adjacency matrix, and in this case, weight can be estimated in our geodesical networks as a distance between nodes or distance between waypoints in air navigation, which can be calculated by simple mass formula, which you can see here, which is the distance between 2 points. Of course, in this case, we need to transform data from a geodetic reference frame to the Cartesian reference frame, because we need to use x, y, and z axes. Thus, by this case, we can easily estimate weight matrix, and weight matrix includes all distances between any two nodes in the network. And weighted agency matrix can be obtained by simple multiplying each element of binary agency matrix R with weighted matrix W. And finally, we can obtain our graph. Uh, what we can do with this graph and what we can estimate. First of all, we can estimate two basic parameters. First of all, it is nodes degree, which indicates number of connected nodes by edges, which can be calculated by quite simple formula, where A is an element of agency matrix, A. And finally, we can obtain a picture like that, which show us nodes which is connected the most in the network. In this case, we can compare different nodes between each other to understand which nodes is the most concentrated in the network. Okay, next, because we have lenses between each node or lengths of each edge, it means that we can calculate weighted nodes degree, which is a sum of edges lengths connected to each node in the network. In this case, we can count the same. However, we will use G, which is element of weighted agency matrix. And in this case, we will get absolutely different picture. However, if you can compare my examples, you can see that two of these nodes has approximately the same highlighted in results of nodes degree estimation. And finally, today I will touch two other quite important network parameters, which is closeness, centrality, which indicate some mean distance from particular node to all other nodes in the network, which is usually used in inverse format. In this case, final results indicates us the most concentrated center of the network. And in this case, we can localize the center of network. And if you have geodata for analysis, in this case, we can compare closest centrality with geodata to compare if there is some difference between them, and it may cause some shift in network configuration that probably not good, because usually center of closest centrality should to be approximately coincides with geometrical center. And the second one, it is betweenness centrality, which indicates how useful is each node in the network. In this case, usually we modeling different paths between between two different nodes in network. Due to possible a lot of different cases, a lot of combination of different paths in the network, usually use the shortest path in the network. And if we get the shortest path between each two nodes in the network, then we can estimate by this formula, relation of how often each node is appeared in this short path in the network. And it shows how often each node is used in the shortest path between two different nodes of network. In some cases, paths at the boundary of network can be used to get like connection through the network. In some other algorithms, they use just the all combination of possible paths between any two nodes in network. However, this betweenness centrality indicates for us the most concentrated waypoints or nodes that can use the highest level of traffic if you talk about transport system. Okay, thank you for watching, and now I would like to switch to MATLAB, and actually now we will start a little bit coding. I will use MATLAB in my PC installed. Just a second, where it is? Okay, it is here. And also I will open editor in MATLAB, and then we will try to code something to introduce the basics of graphs in MATLAB. Also, I will try to show you how we can calculate all of these parameters in MATLAB. And you will see that MATLAB, it is easy, it is speedy, and it is very well for network analysis. Okay, in this case, first of all, let's start as usual from description of code, which we would like to type or create. Then we need to prepare MATLAB environment for further calculation. Thus, first of all, I will use CLC, clear command windows, and clear bars, because we will use multiple different variables, and also we will get many graphs. Thus, I will need to close all graphs because we will have plenty of them. First of all, I will start from the database of network. And in my example, I will use a network of navigational aids within Ukrainian airspace. However, it doesn't matter which network you will use. In my example, I will use coordinates of each waypoint, which will be nodes, for setting up the geo network. I don't want to type too much, thus I just compare input matrices of network database, and here it will be matrix nav, which will include latitude and longitude of each waypoint of each distance measuring equipment in Ukrainian airspace. Next, I will specify matrix DME, which is a string array which holds identification codes of each distance measuring equipment. Then, if I run it, you will see that I have in my workspace variables with latitude and longitude. It will be database and identification codes of each navigational aid. Next, I will need to get identification of different combinations in my network. To do that, I will set up variable s, which will include combinations. And to build combination, I will use function com combinations, and then I will specify number of combination. It will be number of elements created by variable or created by function null from DME matrix, and I will need to use combination by 2. Thus, I will combine only two numbers together. Due to absence of altitude, I think that all my geo data will be located into the ellipsoidal surface. And as usual in civil aviation, we use VGS84 ellipsoid. And in this case, I just set up altitude for my navigational aids database as zeros, as a matrix zeros, which will be column matrix, which holds the size of number of the nodes used by 1. Okay. And next we can transform coordinates from geodetic reference frame to the Cartesian reference frame. In my case, I will use transformation LLR to ECEF. And to set up ECEF, I need to specify latitude. It is the first column of matrix nav. Then I need to specify a column of longitude, and finally column of my altitudes. However, altitudes is equal to 0 because all of them will be located at the ellipsoidal surface. Yep, and going next, let's count distances. Okay, first of all, let's run to see if everything is correct. Okay, thus I've got X matrix. Let's check if I got it. And this matrix includes 3 columns. First of them is x-axis. If you remember, x-axis of ECF reference frame is directed at the point of crossing prime meridian and equator and connected with the center of our planet. Then the axis directed up with rotation axis of our planet, and y-axis just at Cartesian reference frame and is going up through the Indian Ocean somewhere. Okay, thus we've got 3 of these columns in meters from the center of our planet. Then we can count distances which we will use as an weighted lenses of each age in our navigational aids network. Thus, it will be matrix D, and distance is equal to square root from power, then it will be powered by 2. Then we need to find difference between, just a second, actually now we are coding this formula. Thus we will need to find distance between different nodes in network. And to specify different nodes, we've got in matrix S identification numbers of each node in our combination. And in this case, we will use X matrix because it is X, thus we will use first column of X matrix. And then we need to select which nodes we will use as the first one. And in this case, we use identification of this node from S matrix. Thus, S, it will be any columns, because we will use it in matrix way, and we use first column. And then we will find difference with the second identification one. Thus, I need just to change here to 2. Then we will copy everything that we have in power, then plus, and then change it to their second column, which will be related to y coordinate. And in our case, y coordinate, it is we need to specify just 2 here. And finally, to get z coordinate, we just need to specify 3 here. 3 here and 3 here. And also we put semicolon to close our line. Of course, when you type your line in script in MATLAB, always check if you have any mistakes. This square should be green, and if it is green, it means that you can run, and then we can check if we have any mistakes. And also we can check our matrix D, and we can see that distances, it is normal because it is in meters. It means that here it is only 170 kilometers. Thus, it is approximately real data. It means that everything is calculated correct, and we can continue coding. Always check each line by running your script and compare data which you obtain in result. And now we've got weighted coordinates. We have coordinates of each node. We have identification code of each node, and we have lengths of each distance or length of each edge in our network between any nodes in network. And we are ready to introduce and setting up graph. To setting up the graph, I will use function graph. Just MATLAB graph. We will need to setting up undirected graph. Therefore, graph function will setting up undirected graph in our case. There are different ways how we can setting up. However, we've got everything. We will use the simplest one. Therefore, if you would like, just check graph function in your Google. And I am continuing. Therefore, I will use variable g. It will be my graph structured array, and I specify function graph, and then specify uh, combinations which we have. Thus, I will use first column of matrix S. It will be my uh, first identification of node, and then I will specify the second column of matrix S. Sorry, it will be my age specification. Then I specify weight. In my case, weight, it is a distance between nodes. It means matrix D. And finally, I specify titles of each node. I use matrix D. And if I run again my code, let's check if we have any mistakes. You can see that I've got G in my workspace, and G is a graph. If I click on G, you can see that there are two tables, table of ages and table of nodes. If I click in nodes, you will see the column, one column table with identification code of each node. If I click in table of ages, you will see identification titles of nodes, which are boundary nodes for each age. And also this data are accompanied by weight or length in meters between each node. Okay, let's continue. Next, let's set up our agency matrix. In MATLAB, we have also agency, quite easy. Just agency. Yes. And we need to specify which graph we would like to use. And if you run it, you will see that oh, sorry, you can see that I have an error because MATLAB cannot understand this function. Yeah, I miss just C here. And then we can run, and you can see that we've got variable A, and if you click on it, you will see age matrix. However, this matrix is represented in the following form. Here is address of each cell in our agency matrix. And as you know, agency matrix is a binary matrix. That's why it can be true or false only. In my case, I use all ages in the network. That's why all of them has 1 and there is no false values. Next, let's try to play a little bit with plotting of graphs. To do that, I would like to change a section in my code, and I will start from figure. I will create a figure, then I would like to specify color, and it will be white, And also I will specify title, which basically in figure properties is name. And I would like to plot a simple graph. Okay, in this case I will create a figure. If I run this section, just a second, you will see that I've got white background in my figure. I've got separate window which is titled by simple graph type name. Then let's put in this figure our graph. To plot graph, we can easily apply plot function. Just plot, then we need to specify g, and plot function will understand that g is a graph. It is not x and y. Then I will specify marker type, and I will use squared marker, and also I will specify marker size. Size because default size can be too small and it is not appropriate for visualization. And when we run, you will see something like that. I will increase the scale. We've got our graphs, and because it is just a simple graph without weighted edges, in this case, by default, each edge is equal to 1, and and this graph will be optimally tuned to indicate in the window. That's why we've got a form like that. All graphs or all nodes is located as a circle, and only few of them inside of this group of nodes. Of course, if you would like to guide visualization of graph, you can just type graph function and go to the properties of plotting graph, and then you can specify different forms of visualization of graphs. There are not more of them, but approximately 10 different forms of visualization. With for each of them, you can specify particular parameters. Okay, and I think it is time to play a little bit with weighted graph, because this one is not informative at all. That's why I would like to create another figure, and in this case it will be weighted graph, how I call it, and also I will copy plot function here. However, in this case, I will specify data with the reference frame. In plotting graphs, in this case, we can use properties of x data, and in this case, I will specify latitude, which is called, which in this case I will specify longitude, which is specified in matrix navigation, second column, and I will specify y data, y data, and it holds in first column of matrix navigation. Okay, and also I will use marker, and let's check it to circle. Marker size 13 will be well visible. Also, in this case, we will get like geo-located graph. In this case, we can specify y label, and in my case, it will be latitude, which will be in degrees. Just I specify just deg. Then x label. X label, it will be longitude. Gitude, also in degrees. Also, we can specify title, because probably we will copy this picture to somewhere. That's why we need to know of the title. Therefore, it will be just weighted graph. And to make some reference, I switch on grid. That's why grid on. And probably we can run this section by clicking Ctrl Enter. And we can see graph as this one. Probably, sorry, we have some mistake. Let's check our command window. Okay, we've got problem that C is not recognized as a property of MATLAB. Yes, circle is O, sorry. Shame on you, Ivan. That's why you need to specify O here. And then if we run, okay, we've got a picture as I would like to represent for you. That's why here you can see node with setting up coordinates in reference frame of latitude and longitude. Also, you can see identification codes. It will be automatically indicated in plot function. That's why you do not need to use text function to specify identification of each node title. And also we can see multiple edges which connect each pair of nodes in our imaging network. That's why let's continue. If you remember, next I would like to estimate some parameters. And if you remember, a second, in my picture, these parameters, it was nodes degree, weighted nodes degree, and closest centrality and between centrality. That's why let's start from nodes degree. I will switch to my figures. Also, I will create new section because I would like to prevent to resimulation all the code again. That's why I will open new section and then continue typing in this section. To do this one, I will copy all previous data. Then here I will specify just nodes degree, nodes degree. Then I will copy it to the title of graph because later we can forget about it. Then we've got the same. However, we will need to specify a picture which we got at the end. Therefore, we will create variable p, which is equal result of graph building, and then we will count centrality. That's why I will introduce matrix W, or maybe it will be results. Okay, maybe it will be just W, and it will be some matrix with a number of columns and rows, and first column of this matrix will be equal to centrality data. That's why I call centrality function of graph G, and I would like to know degree of this graph. And after that, we will obtain nodes degree in our graph for each node. Then, to specify this data by color in plot, we will need to change color data in my graph. That's why I will call P, because P holds a graph, and I will specify node color data, and this data will be equal to node degree, which we just saved in matrix W. Also, then we need to specify color map. I will use jet. Then also I will specify color bar, and also specify title of this color bar. That's why I will use y label of age, which is color bar, and I put node degree. Okay, and if I run it, Control Enter. Okay, sorry. However, I've got some mistakes because I do not have result which I expect. Okay, see color map. Of course, color map. Let's run again. And we will see picture like that, and this is correct because due to our code, if we come back to age setting up, we will use combination of all two nodes in our network. That's why we've got 70 nodes. It means that we have 16 degree of each node. That's why in our graph, node degree is equal to 16. If you would like to play a little bit, let's just switch off some ages by deleting some variables. For example, let's delete ages from 24 up to 27. We can do it quite easy by deleting rows in our matrix. And in this case, we will need to run all the script from beginning because we will change S matrix. And now you will see that our node degree will be different, and you can see that the most nodes has 16. However, some of them which use probably deleted ages has been affected by deleting these ages. That's why number of nodes has been reduced probably to 15 and some of them for 12. That's why here we've got blue and four orange, four orange of them. Okay, let's then try to estimate weighted centrality. Weighted centrality. I don't want to retype all of that. That's why I just copy all this code, create new section, then specify weighted, not degree, also word weighted. I will specify here, weighted not degree, and in the title of our figure. Weighted not degree will be calculated by adding specific properties in degree. In this case, we will need to specify importance properties. Also remember that the most properties start from capital letter. That's why we need to specify with a capital letter importance. And then we will setting up weight of each ages. Weight. Okay. However, this data I would like to save at the second column of matrix W, and also it will be another plot because it is a good behavior to use different variables in this case, because in some cases it may be coincide and you will get mass of data. That's why if it is possible, try to introduce different variables. And if I apply Ctrl Enter, I will run it. I will have weighted not degree. Just a second. If we can compare it with a simple not degree, you will see that it will be absolutely different. And in this case, weighted not degree, it is sum of ages lengths from each node. That's why, because length in meters, that's why weighted not degree will be in meters. That's why, sorry, we need to specify units, meters, and everyone can understand that it is okay. It's like 120 kilometers. That's why it is normal value. No, 1020 kilometers. It is because we have up to 16 ages for each node. That's why we've got quite valuable value here. Next picture which I would like to show you, it is closest centrality. Therefore, I just retype title, closeness, centrality calculation. Also, I will put this title in the description. In this case, we do not have units because it will be some unmeasured value. Okay, next I will change variables for the second one, and also I will change to the third column, and color bar also will be different. Okay, and next I will specify the closest. In this case, we need to change degree to the closeness property, and then specify cost. And as cost, we use our usual weight. That's why let's run in this case, and we've got closeness centrality. And in this case, closest centrality will indicate us the center of our network. That's why this 1, 2, 3, 4, 5, 6 nodes forms a center of network. All other nodes are located far from the center. In the big, huge network with a big amount of nodes, it helps to identify the dense of network, because in this case we can specify center of network and dense and spatial network. As an example, this node is located at the maximum distance from this center, and in this case closeness centrality indicate it by numbers. That's why closest centrality helps us to identify the ideal network center and specify their elements which is located far from the center, and we can use it to estimate if it is geodata. We can use it to estimate like shift between network configuration center and geocenter of this network. And if you would like to get maximum performance, it should to be coincides between each other. And finally, let's estimate betweenness centrality. Also, I will use the same part of code because I don't want to type a lot. I just change closeness centrality to the betweenness centrality. And also I will copy in betweenness and then put it in the different places in my visualization. Also I will change variables p3, I will create fourth column, also fourth column, and also I will create, I will change color bar properties. Okay, and then to change closeness centrality to betweenness centrality, we just need to change closeness property here to the betweenness. That's great, I like it. That's why we just need to change one word in our code and we will get absolutely another property of our graph. And due to deleted 4 edges from our network, you will see that some nodes are appearing much more frequently in their shortest paths between any two nodes in network. And in our case, it is like ideal case, it is not real case. Even coordinates of these navigational aids is not true. That's why I changed it a little bit, because it is used only for study purpose. And in this case, you will see that Kryvyi Rih and Yahatin navigational aid and KSN is much more frequently used in the shortest paths in the network. And it means that this navigational aids, if it will be traffic network, will be the most loaded in comparison with all other nodes in network. That's why betweenness centrality indicates for us a lot about load of different nodes in network. Okay, if we've got everything in our code, let's run everything from beginning and see what figures we will get. That's why I will run it, and I just move to my my screen results of my simulation. That's why I will start from beginning. I've got 6 different figures. That's why we touch simple graph building. Then we build weighted graph. Then it was node degree. Then it was weighted node degree. Then it was closeness centrality, which shows us center of our network and also identify elements which is located far from the center. And betweenness centrality indicates the most busiest waypoints or nodes in network if it is transport network. More information about it you always can find in different resources. That's why you will need just to copy and paste your request in Google, and you will find answer. Just don't forget to add MATLAB and then question. One more thing, if you would like to know more about graph function, just type it in Google, and I will come back to the graph. However, just a minute. Centrality. I would like to show you centrality properties. Just a second, and I will go to. That's why you will see that closest centrality in a more complicated transport network shows their center of network. Okay, and betweenness centrality shows first the busiest waypoint based on configuration of network. I would like just to show you options for different properties of closeness centrality. That's why we used degree properties option, and we use closeness and betweenness. Degree, simple degree or importance degree if we would like to use weight. For closest, it is a cost properties, or in like MATLAB description, it is name value argument. And betweenness options also use cost argument for input weights for our graph. In this time I just would like to say you thank you for being with me. I am glad to serve you in study MATLAB. If you will have any questions, I will be glad to answer. Thank you very much for watching. Hope to see you in our next meetings. Bye.